We're at BSDCan this week, but fear not, we've got a great interview with Sephi, a DragonFly developer, about their network stack. After that, we'll be discussing different methods of containment and privilege separation. And of course, assuming no polar bears eat us, we'll be back next week with more BSD Now. So keep it tuned to BSD Now, the place to be. SD. BSD Now, episode 93, Stacked in Our Favor, recorded June 3rd, 2015. Hey, I'm your host, Chris Moore.
And I'm Alan Jude.
And we're glad to have you guys with us this week. We're recording this a tad bit early. You may have noticed the date on the tag there. But, of course, we're in BSDCan, so we had to give you guys something to watch while we're gone for those who couldn't come out and join us. I'm sure we're having a good time at this point.
Yeah, we'll be. This will be the middle of the Dev Summit, probably. So
I think I probably will have had shawarma by this point, too, which is fantastic.
But for the first time ever, the Dev Summit is being recorded and will be posted for everybody to watch. So that is definitely interesting for people that have never got to attend a Dev Summit before and see how much different it is than just the regular conference talks.
Definitely. So, it's going to be a lot of fun.
What was that's my favorite part of the conference always. You know, and because it comes first usually, except for I think one conference I've had it after. I forget which one. Anyway, but because it comes first, you know, it's where all the cool stuff. And then by the conference, you're already just like, okay, so much stuff to do.
Yeah, that's right. But definitely going to be a fun conference. I know we're going to enjoy it and hopefully come back with a load of interviews that we've been able to do in person as well. But we were just talking, Alan, about who the keynote speaker was going to be for this. So can you go ahead and spill that for us?
Looking at the schedule, the keynote will actually be Stephen Bourne. And if you're not familiar, Stephen wrote the original SH, the shell that spawned all shells.
That is just too stinking awesome.
Yes, and on top of everything else and answering lots and lots of questions about SH, he'll also be talking about memory management and interfaces used to do stuff, especially since there were no C stack at the time when he was writing this. The fact that SH has no string lengths or anything, and it's all or any other arbitrary restrictions, and what that meant when you're actually trying to write it. The SBRK and the porting grief people had trying to get SH working on different platforms. His opinions on the shell shock vulnerabilities and Bash, and the fact that those had been laying around since the early 90s and nobody had found them until recently.
Right.
Tricks used and why.
Well, nobody had publicly said they had found them until recently, right?
Exactly. And some of the tricks they used and why when they're building SH, reasons why we did this and that and the other thing and why we wouldn't do it that way if we did it today. ADB and interesting problems it runs into on, one machine is debugging another, but it's compiled on a third machine and so on. And then why he wrote the Alog 68 port and got Dennis Ritchie to add overlays or exec support. His the invention of environment variables and why that happened, and how he talked Dennis Ritchie into including the void context into C and the other C changes that spawned because of the shell and so on. And also an explanation of why Bill Joy wrote C shell instead of just using the Bourne shell like everybody else.
Right. Wow, this is definitely it's going to be a great keynote.
Exactly.
Man. I'm excited.
That's just how we're starting off the conference. Then you're looking at the talks, and building packages for embedded platforms with QEMU, Signify.
Bruno and Stacy's son are doing that. Yep. I'm going to go to that because, building ARM packages sounds cool.
Yep. And then they have Ted Unix talking about Signify for OpenBSD, even faster virtual machine networking and virtual pass-through. This is, I think, what I'm going to go to because it's about making networking and Beehive and Zen and so on faster, using NetMap and so on. That one's definitely but then Ken is also doing his Lumina talk, which I've not actually played with Lumina yet, so I kind of want to see what's going on over there as well.
He will be able to give you a demo of it, definitely on his laptop and, of course, at the talk as well.
Yes. Also, as we've done before, there will also be a Dev Summit public demonstration track. So while the Dev Summit is private and invite only on the Wednesday and Thursday, on Friday there will be a series of short demonstrations and other talks and presentations and so on, based on what we came up with, and presentations from each working group and so on. That will be going on as a fifth track. As if you couldn't decide between the 4 talks that are going on the schedule, there will also be stuff that will be added at the last minute and go in that track.
Mm-hmm.
And that's just the first hour after the
that's a whole conference right there. I'm done.
Exactly.
Right?
That would be enough for a whole conference. But after that, they also have adding AES, ICM, and GCM to the Open Crypto Framework from John Mark, virtualization for ARM, microkernels in NetBSD by Andrew Tannenbaum. We some people saw an older version of that talk in Bulgaria. Mm-hmm. But also Alexander Motin will be talking about feature-rich and fast iSCSI targets using CTL and ZFS. Or, sorry, just SCSI even. So making the SCSI subsystem faster so that you can get even faster ZFS and serve off those disks to CTL, which is the iSCSI, even faster. Mm-hmm. Then over lunchtime, on top of I'm pretty sure we'll have the improved lunch from last year instead of the box lunches from the years before. Once you pick up your lunch, you have a choice of 2 different birds of a feather sessions to hang out in while you eat lunch. I'll be running one on Beehive, and Michael Shirk will be running the MetaBoff, which is Metabug is online.
Surprise! While you eat, you get to talk about BSD still.
Yes. So Metabug is kind of like an online BSD users group that kind of intermingle stuff from all the other BSD user groups, and they'll be having that going on. And then after lunch, this is still only the first day of the conference as well. Yep. George Neville Neal and Jim Thompson will be talking about measure twice, code once, doing performance monitoring and measuring for the network stack. Then Ryan Lordy will be talking about JH build and a portable way to build software. Then Brooks Davis will be presenting Cherry BSD, the research fork of FreeBSD that uses the capsicum type stuff, but built right into the processor. Yep. And then Kevin Bowling will actually be presenting FreeBSD operations at Limelight, which is a big CDN. They were distributing like the GTA 5 download that everybody was downloading So they've dealt with like massive scale, all using, I think they have 10,000 FreeBSD servers. Wow. So it'll definitely be interesting to see what he's presenting. Mm-hmm. And then Shani Michaels will be presenting expanding RDMA, which is remote direct memory access, for doing remote direct memory access over Ethernet in FreeBSD. That sounds really cool. Then there'll also be molecular evolution, doing genomic analysis on FreeBSD. So using FreeBSD for medical research, which is definitely cool. Ed Mass will be presenting LLDB, which is the Clang debugger, and then Brian Callahan, and who's a frequent contributor to the show, and George Rosamond will be presenting how to build a BSD user group based on their knowledge from building the New York City BSD user group, and that'll be interesting to see more BSD users groups popping up around. And then we have protecting FreeBSD with secure virtual architecture, and then Olivier Calab, who does the BSD router project and was the original founder of FreeNAS when we talked to him in Bulgaria. He is also large-scale plug-and-play x86 network appliance development over the internet, talking about using NanoBSD, OpenVPN, Ansible, and so on to automate the deployment of big routers. They'll also have a presentation about running FreeBSD on the ARM v8s, and Warner Losch's talk about I/O scheduling in the CAM layer, which was... he's doing that for Netflix, and their basic concern was we need to be able to write to our disks as fast as possible, while at the same time not actually slowing down reads from our disk and scheduling that. So that seems definitely interesting. And then after dinner, on top of, there will be a doc sprint, which is basically the documentation group and anybody who's interested in working on it or helping with it can get together, and there'll be a bunch of doc committers, and they'll work on documentation and closing bugs and everything they can do to improve the documentation. If you're at all interested in getting involved, you should definitely check it out. All the experts are there. They can help you get started. That's how I got started 2 years ago. And then later in the evening, there's the Hacker Lounge, which is basically a big open room with power, and everybody's sitting there working on stuff.
Lots of laptops, lots of beer,
Yep,
and hopefully a lot of hacking.
Yes, and it's immense fun. I think last year I was there until 2 or 3 a.m. every night of the conference. It was crazy. But also co-located there will be a PGP key signing party. So make sure you bring your passport. And they'll be doing a big key signing party, which will be good.
Okay.
And that's just the
day
first
one.
day. Let's quickly go through the second day as well. Ed Schouten will be presenting Cloud ABI, which we had an interview about very recently, but that'll be very interesting to see what everybody else thinks about that. And then they have an interestingly named talk, What Happens When a Dwarf and a Demon Start Dancing by the Light of the Silvery Moon? Which is about embedded.
That is something. Okay.
Also, George Neville Neal and Robert Watson will be presenting the courses they've been developing. Cambridge L41 Teaching Advanced Operating Systems with FreeBSD. Based on their the courses they're designing to be university courses, and that material will be open source.
College, I didn't get any courses like that.
Exactly. Well, they're going to be open sourcing the material as well,
okay.
so that it can be taught at many different colleges, and you'll be able to get to it. Also, the PCI SR-IOV on FreeBSD will be presented. This is the hardware-assisted virtualization of PCI devices. That's where you have a 10 gigabit network card with maybe 2 or 4 ports or whatever, but you can do PCI pass-through of virtual ports. So even if you have 1 gigabit or 1 10 gigabit port in your machine, you can pass through a virtual port into each VM so that you're not doing any virtualized networking and the NIC's doing all the work, and basically allows all of your NICs to share that 10 gigabit NIC without any virtualization overhead. So that's a really big thing that people are interested in. Then Matt Ahrens will be presenting his OpenZFS features supporting remote replication and so on. We saw that in Tokyo. It'll probably have even some more advances, including much more concrete deadlines when it'll actually show up in FreeBSD, because it should be really soon now.
Yeah.
Maybe even hopefully in time for 10.2. We got to rush somebody on that.
That would be nice.
We have to
let's bug them about that.
We'll tie him down in the Hacker Lounge if we have to and get it done.
You don't leave until this gets committed.
Yep. Then Randy Harper will be presenting her fighting harassment with open source tools. There's been a lot going on in that space. And then that's up against my talk, UCL for FreeBSD, which is presenting the work I've been doing, including converting Beehive to use a UCL config file, and lots of interesting stuff. And will also contain the results of our working group meeting, which will be happening earlier in the week on the Dev Summit, up against Ray Percival's networking with OpenBSD in a virtualized environment. So that one's definitely interesting as well. And then we have lunch again, and during lunch there'll be a series of BOFs again. I'll be running one on OpenZFS, and George Rosamond will be running BSDs and privacy technologies, talking about Tor and encryption and all those other interesting things. And then after lunch, we have multipath TCP for FreeBSD, which we're hoping to have an interview about soon as well. So this is implementing multipath TCP so that you can, if there's one router along the path that's actually slowing things down, we can actually be using multiple routes at the same time to get the packets to the endpoint. Currently, some iOS devices support this, but will only turn it on if you're talking to a known Apple IP address. But eventually this will be an open internet standard, and it'll be great for FreeBSD to be leading the way on that. And then Peter Hessler will be presenting his using routing domains and multiple routing tables in a production network. Chris Moore, who's that guy? I've never heard of him. Will be unifying jails and package management in PCBSD, FreeNAS, and FreeBSD with a browser-based package and jail management tool. I haven't actually seen that yet.
The new slides. No, I will show you, and I'll have to write the new slides about us using IOCage for the jail management now. So that's some of the new stuff I got to add.
If you remember when we were in Tokyo, we got a taste of that we got to see that 2U machine that had 48 8-core atoms in it. And if you fill the rack, you get over 5,000 cores. Well, they're actually going to tell us what you would use it for and how it would work. So we saw FreeBSD 10 running on one of these in Tokyo, but we didn't get to hear much more about it other than, hey, there's this thing, and you can run FreeBSD on it, and it's great. but there might be a full talk, FreeBSD with high-density servers, how to set up and control an Avoton-based 5,000 plus core micro-modular server.
Yeah, that's going to be interesting.
Yes.
Wait, that's up against my
It
talk.
is.
Darn it.
Luckily, it'll be recorded. I know, because
Okay.
I was like the same thing. It's like, I want to see that, but I have to
Yeah,
be in this other room. And then Baptiste will be presenting packaging the FreeBSD-based system. It's like, yes. And we were promised that by now we would have a beta for developers.
Yeah, let's make that happen. Again, another person we will not allow to leave the room until something comes out of that.
Yes, we'll bribe him with beer if we have to. And then Michael Dexter will be presenting FreeBSD virtualization options, talking about the latest developments in Beehive and Zen, which are both available on FreeBSD now. And then we also have extensions to FreeBSD for data center TCP for incremental deployment support. So data center TCP is a way of centrally managing the latency between servers. And it looks really interesting. And the biggest thing is that it kind of, when it was designed, it was kind of all or nothing. But they're working on a way of incremental supporting it so that, a machine has optional support for it, but can talk to machines that don't, and kind of rolling it out. That one seems definitely very interesting as well. And then Rakefloiter is introducing OpenBSD's new HTTPD. And then before the closing session, the last set of talks are an introduction to the implementation of ZFS by Kirk McCusick. If there's anyone that can explain the complexity of ZFS very well, it would be Kirk. And then 7 will be presenting Adventures in Building Open Source Software, a year of tinkering with package source and other such things. Ingo will be presenting Mandoc, becoming the main BSD manual toolbox, especially now that Mandoc is the default in FreeBSD and I think almost everywhere in BSD now. And then also the guys that do Jetpack, which is one of the things kind of like Zocker that we were talking about. They'll be presenting Jetpack, a container runtime for FreeBSD, breaking the Linux Docker monoculture, and he'll be giving his presentation.
I may need to go to that. We'll be keeping an eye on that one.
And then there's the closing session. Well, Dan will wrap up stuff. There'll be presentations from the other conferences coming up. And then that will also have the famous BSDCan auction, where they auction off leftover stuff, donated stuff, everything, and all the proceeds go to a local charity. But I have a couple of things to donate for that as well.
Okay.
So, and I didn't mention, but on the after the closing event, there will be a closing social event. So a dinner thing. They were smart and put it at the end of the second day instead of at the end of Saturday, so as not to kill off most of the Hacker Lounge on Saturday. Once all the conferences are, or especially the problem with having the social event in the middle is that anybody has to speak the next day cannot have as much fun. But once the conference is completely over, you're welcome to have as much fun as you want at the social event. And apparently we're actually taking over a part of a whole neighborhood or something in the commercial district. So the social event sounds like it's going to be very good.
Yeah, that's going to be a blast.
And finally there will be the Hacker Lounge. Once anybody who's had enough partying but wants to get some work done, there'll be Hacker Lounge the final night as well.
So as you can see, folks, we're going to be pretty busy next week. This is going to be, and we didn't even talk about all the stuff happening at the Dev
That'll
Summit,
be this week when they're watching it, right? Because
when you're watching this, we will actually be out there doing.
Yeah, we'll be like right in the middle of all this craziness. So you understand why we decided not to try to do an episode remotely or something.
That's right. But yeah, it's going to be a lot of fun. Definitely looking forward to it. You're heading out in a couple of days, Alan. I'm heading out in about a week. So, definitely looking forward to getting out there and enjoying this year's BSDCan.
Yes. Also, if you're looking to take the BSD professional exam, it'll be happening as well.
Yes.
It happens. The BSDA certification exam happens during lunch on the first day, and the BSDP exam is on the Sunday.
Okay.
Because you need a whole lab for that.
Yep. Well, sweet. Well, again, don't feel sorry for us. We're having a great time. And again, so if this doesn't make you drool, first of all, there's something wrong with you. And second, make an effort to get out there next year or to another BSD conference.
There's lots of ones coming up.
Close
BSDCan is September 11th through 13th. which includes the 11th is a Dev Summit. So
Yep.
if you're interested, we'd love to have more people. Well, the Dev Summit is great, and you'll get to see videos from that. And then, BSDCan was great 2 years ago when there was one, so I'm looking forward to that. And then we have EuroBSDCan in Sweden. So if you don't want to fly across the ocean, then you can do that. Or if you're if that's also too far, then we'll have Asia BSDCan will be coming up again in March of next year.
Okay. Well, great. Well, before we do this week's interview, of course, we do need to mention one of the sponsors this week, which is going to be DigitalOcean, who we're starting with today. Where, while we're out of town, maybe a little shorter episode, maybe you have some free time now, and you can go set up your DigitalOcean droplet, get FreeBSD queued up in that sucker, and start messing around. Definitely, they offer a lot of options to do that. And of course, you want to use the coupon code FreeBSD Now, which gives you a $10 credit, which is good for about 2 months of running a droplet. So definitely a lot of time to play around with it before you're even paying for it, which at $5 a month, come on, it's not a lot, especially for something backed with all SSDs and great connectivity, lots of bandwidth. Yeah, this is fantastic. We're joined now by Sephi from DragonFly BSD. So first of all, thank you so much for coming on the show with us this week.
Yes, thank you.
Yes, considering this is actually the second time we tried to record this interview in the past, and I screwed it all up.
It's all okay. It's all
so
okay. We all make mistakes.
It should be more polished, right? You guys are getting like the official release version. The other was a beta. So, okay. So, Sephi, go ahead and tell us a little bit about yourself. How'd you start and get into BSD in general?
I'm a programmer and I live in Shanghai. I first met BSD when I was in university. A mate introduced FreeBSD to me, and before that I only used the Linux. But since then, BSD becomes my only choice. And I use the NetBSD and the OpenBSD too. But I liked the FreeBSD more when I was in university. And then, of course, DragonFly BSD after I graduated.
Okay, nice.
Cool. So what attracted you to DragonFly BSD specifically?
At first, it was how DragonFly handles its network stack attracted me. And after I started to work with DragonFly folks, the friendliness of the DragonFly community also makes it very attractive. And you really can learn a lot from the symbolic DragonFly BSD folks like Matthew Dillon and Jeffrey Su.
Cool. So what do you usually work on in DragonFly?
I usually work on network-related stuff, from kernel-side socket code to network device drivers. I had ported many network device drivers from other BSDs, and I also had written some network device drivers myself. And in the past 3 years, I brought more TCP-related RFCs to DragonFly BSD and improved its network stack concurrency. And there are many other stuffs that I worked on. For example, APIC, power management, interrupt routing, and some machine-dependent stuffs. Well, it actually depends on how many stuffs that are not working on a new machine that I got. So
yes,
many different stuffs.
Of course. So for those of us who don't know, explain to us what some of the major differences are between DragonFly's network stack and, say, some of the other BSDs.
Okay, unlike others, DragonFly's network stack is not using lock, but using message and thread to serialize network operations. Each CPU has its own thread for network operations, and some network data are replicated to each CPU. For example, the routing tables. And some network data are partitioned between different CPUs. For example, the TCP and the UDP control blocks. And some network stuffs are just per CPU. For example, the statistics for TCP and IP. And let me give some simple examples about how it works. If userland application wants to send data, it will first send a message to a per CPU network thread. And that network thread will take care of the network protocol processing and put the packet to the network hardware.
Okay.
So that thing is going on the network. And then on the other hand, when the network hardware receives a packet, a hash is generated for the packet, and then a per-CPU network thread will be selected based on the generated hash value. The input packet is then queued to the network thread, and that thread will handle all the network protocols. And after the packet is processed by that thread, it will be queued to the socket's reception buffer. So the whole thing just gets flows.
Okay.
So what are some of the pros and cons to that kind of threaded serialized network stack?
The pros are the stack is lockless, so there are no lock contentions. And you don't need to worry about locking order at all. It will be very useful, especially when you are working on a complex subsystem like TCP. And cache pollution is pretty low, since network data are either partitioned, replicated, or is just per CPU. Each CPU only works on its own data set. And since all network operations are carried out in a given set of per CPU network threads, things like packet transmission aggregation and TCP acknowledgement aggregation are implemented without too much trouble there.
Okay.
And let me see, the cons are mainly memory consumption. The memory consumption for the replicated network data. For example, the full BGP routing table will consume more memory in DragonFly than other lock-based network stacks. Because the routing table is replicated to each CPU in DragonFly. But I think for the modern hardware, extra memory consumption actually no longer matters that much, since the memory is pretty cheap nowadays. And if you have a large CPU configuration, you usually has more memory.
Sure.
Right.
So
ahead.
you may have heard that some early network studies say that thread serialized network stack is slower compared with the lock-based network stack. It's mainly due to the scheduling cost. And several years ago in DragonFly, we also noticed that the scheduling cost. However, it turned out that the root cause of the high scheduling cost is the usage of synchronized messages. It does not have anything to do with the network stack model at all. So we then switched to use asynchronized messages to avoid the scheduling cost, and that also greatly increased the pipelining effect on the whole network path.
Okay. So how exactly does the stack go ahead and partition your network data?
Let me see. We calculate hash based on IP addresses and the TCP port tuple. The hash function is applied to both input packets and the sockets. And based on the hash value, DragonFly assigns the input packets or sockets to one of the per CPU network threads. When the DragonFly network stack was thread serialized in 2003, we used a simple hash function, and all hash calculation was done by software. But in 2009, we began to exploit the hash calculated by network hardware. It is part of the hardware receive-side scaling. It is also known as the RSS. The idea is to let the network hardware calculate the input packet hash for us, so we could use the hash value directly.
Okay.
This relieves us some computation burden and avoids a certain amount of cache pollution between the CPU handling the network hardware interrupt and the CPU running the network processing. And then DragonFly just calculates the hash for the TCP and IP for the TCP and UDP sockets using the same hash function. And we just use 2 bytes to seed the key of the RSS so that the hash value is commutative for IP addresses and the TCP port tuple. It's mainly because the TCP port is only 2 bytes, so we will have to seed it, only use 2 bytes. It is pretty important for DragonFly, since both data sending and input packets processing for a given TCP connection must be handled in the same per CPU network thread.
Right, because the data about the socket is only on each CPU.
Yeah.
To reduce the locking. Cool.
So, yes.
Are there any other interesting features you really like about DragonFly in general, or about the networking capabilities specifically?
We have many useful TCP-related RFCs implemented, and I think some probably only exist in DragonFly. For example, let me see, early retransmit, limited transmit, and SAC-based lose recovery. Its performance is pretty good. And IFO detection and response algorithm. These algorithms helps TCP avoid doing unnecessary lose recovery. And let me see, TCP non-congestion robustness. It avoids unnecessary faster recovery due to out of order TCP segments. And let's see, the polling. Yes, the polling. We adapted the polling inherited from FreeBSD to support multiple queues on the modern network hardwares. The code we inherited from FreeBSD only polls the network device itself. Because at the time the polling code was developed, there were no network devices supporting multiple queues. And since modern network devices queues operate independently, per CPU network thread could post the reception queues and the transmission queues assigned to them without contending the hardware resources. And with this in place, DragonFly can fully utilize multiple queues of the modern network devices and enjoy all merits of the polling. Like limiting CPU time spent on the network processing to avoid the DOS attack. And let me see. Matthew Dillon's fair queue packet scheduling is also very, very interesting and useful if you want to prioritize and control network bandwidth usage. And we implemented an interesting extension to SO reuse port. It was originally proposed to Linux by Google. The basic idea behind the SO reuse port is that for a TCP server application, you usually have one listen socket to accept new connections. And that socket is normally shared by many processes or threads. But this kind of sharing causes two problems. One is accepting queue contention, and another is uneven sockets distribution. The extension to the SO reuse port allows those processes or threads to create their own listen socket on the same port. So there's no contention on the accepting socket anymore. And in DragonFly, the accepted sockets are distributed to the SO reuse port listen sockets using the same hash function that partitions the network data. So the uneven sockets distribution is also fixed by it. And we even patched Nginx in our deports package system to utilize the SO reuse port extension. And it gives us great performance improvement. And I think recently upstream Nginx also accepted our patch, and it has the SO reuse port extension support in the newest version. I think the version is 1.9.1. Yes, they have it.
Oh, cool.
And most recently we introduced the IPFW3 from Bill Yuan. It's a modularized version of IPFW we inherited from FreeBSD. And it will be easier to be extended in the future.
Oh, that's nice. So since you guys are... Oh, go ahead.
And besides DragonFly's network stack, Hammer file system is one of the most interesting features of DragonFly. It is capable of mirroring, recovering deleted files, and taking snapshots, and many others. Well, it has too many functions to be described briefly. And let me see. Swap catch. Yes, the swap catch. The swap catch utilizes SSD as swap space and could catch file system metadata and even file data themselves. It does not depend on the file system that you are using. It's generic. It greatly improves the file system performance, especially on the read side, if the storage of the file system is on slow hard disks. And let me see. And we have virtual kernel. Virtual kernel is an interesting idea. It allows the whole kernel to run in the userland. You can have multiple copies of kernel running at the same time, and I think restarting virtual kernel is pretty fast. So you don't need to reboot the machine at all for certain types of kernel development. Yeah.
Okay. Well, since you guys have so much going on under the hood that's quite a bit different, what's this look like up at a top level when you're looking at network performance here? How is this benchmarking out in the real world?
Okay, let me see. The data were gathered when I was working on the related areas, so I think some of them may even improved over the time. But let's see. For the IPv4 forwarding, we were doing 5 million packets per second in both directions. This value is pretty close to the theoretical limit for a system with 4 GIGA ports. And for bulk data TCP performance, on a system with 2 10 GIGA ports, we were doing 18 gigabits per second in both directions. And for TCP connect and the close rate, on a system with 1 10 GIGA port, we are doing 380,000 connections per second with the SO reuse port extension, and 100,000 connections per second without SO reuse port. So as you can see, the SO reuse port extension gives us a great performance improvement. And for UDP request and response rate on the system with 110 GIGA port, we were doing 1.39 million transactions per second. I think that value is pretty good.
Yeah,
and
for sure.
And the last, the NGINX HTTP performance result, we were around 49,000 requests per second. And well, I think DragonFly actually could do more. Since when the performance was measured, I cannot find more boxes to run the HTTP perf. And the DragonFlies and the server CPU still have many idle time. So
Okay.
Lots of headroom left then.
Yeah, definitely.
So is there a lot of cross-pollination between DragonFly and the other BSDs?
Yes, of course. Our TSO implementation references NetBSD's TSO implementation. And we took OpenBSD's packet filter and the COP. Let me see. And we also took FreeBSD's wireless stack. And many network device drivers were ported from other BSDs, and some of DragonFly's network device drivers are also ported to others.
That's
Right, and you're
cool.
saying a lot of the wireless and stuff in DragonFly comes from FreeBSD?
Yes.
Cool.
Okay.
Yes, they also have took some. I think they also took some fixes from DragonFly. Yes, it's founded by Matthew Dillon, and some network device drivers, yes, especially the wireless one, were ported to FreeBSD, like the drivers for the early Broadcom chips.
Now, if we can just get you guys to somebody to port the Xorg stack.
Yes,
right?
DragonFly has the most advanced of the non-Linux open source
BSDs.
of all the BSDs as far as the Intel graphics drivers go.
You're killing me. Well, cool. Well, is there anything else you'd like to mention before we go here, Sephi?
Yes, I think you probably want to watch out for the Hammer 2 file system.
Okay.
It is currently actively developed by Matthew Dillon. It has many new features, I think, like multiple masters. It's very interesting. Much better than the first version of the Hammer file system. And I think it will become the shiniest feature of DragonFly BSD once it is done.
Oh, fantastic. Well, we'll look forward to covering that on a future episode. That sounds good.
Yeah.
Well, thank you so much for being on the show with us today, Sephi. We really appreciate you making the time to do this, especially since we had to retake it again. So.
Okay, but also thank you for the interview.
No, thank you.
Yes.
Okay, I hope you guys enjoyed the interview. So before we go to a discussion segment we're going to have today, we do want to, of course, mention one of the other sponsors, which is going to be IX Systems. And where you want to go is ixsystems.com/BSD Now. Get in touch with those guys. Let them custom design the next solution you need for storage or servers or crazy network machine with tons of 10 gig ePorts. I mean, who knows what it is, but whatever it is, those guys can custom build it for you and get it to you on time. The white glove service the whole way through. So definitely need to get in touch with IX. So when are you ordering some more, Alan? What's your next server you
Probably
can show us?
shortly after BSDCan, actually.
Okay.
We're going to need more storage. And more. Lots.
Well, is this going to your house?
No.
Because we need to get pictures of you. No, okay.
But yeah, I think this is actually going to go in a data center as well, but I should be able to get pictures of it.
Nice. Well, definitely. We will look forward to seeing that. That's always a New Gear Day is one of the funnest days.
Yes.
But anyway, so again, guys, ixsystems.com/BSD Now is where you can go fill out the form, let them know that we sent you, and get in touch with those guys and just tell them what you want to do. Explain it to them, describe it, and then they'll help you figure out the best solution from a hardware perspective and software perspective that'll get you the most bang for your buck and best performance.
Yep.
Okay, so next up we have a discussion segment this week, since of course this is a pre-recorded episode, and we're going to talk a little bit about comparing different types of containment methods and of course privilege separation.
Yes.
So this is a hot topic, and there's a lot of different ways to skin this cat. A lot of different technologies out there, which all do slightly different things, but maybe you're trying to accomplish the same goal.
Yep.
So first, of course, is permissions and users, which been around pretty much forever.
Yeah.
So
like,
this is
if it doesn't need to have root permissions, then run it as an unprivileged user.
That's right.
So then you have the problem of, sometimes certain operations require root privileges. For example, binding to ports less than 1024 requires root. So to listen on port 80, you need to be root. So web servers quickly acknowledge, okay, what we do is we'll have a master process, we'll listen on port 80, and then it will start a bunch of sub-processes as an unprivileged user that will then accept the connections. And that's how, Nginx and Apache and so on work. And so they run as a less privileged user so that when they run a PHP script or a CGI script, or if someone somehow compromises the actual web server somehow, it's just contained to running as a user that really doesn't have access to anything.
Yep. That makes sense. So, of course, this is pretty common practice with both in, of course, the BSDs and outside projects, Nginx, as you just mentioned. But, of course, you can take this a bit further and, fine-tune it and tweak it with using your chmod and chown and per-user UMass settings, changing home directory settings, making it a little bit more private. You can use that to prevent other users on the system, except for root, of course, from seeing your files or even getting a directory listing.
Yes.
So,
when I used to run a shell server, one of the things we do is change the permissions on the home directory, the root home directory, so that you had the execute permission, but not the read permission. So as a regular user, you couldn't get a list of all the home directories that were there. If you knew the name of another user, you could cd to their home directory because you knew it was there, and you had the execute bit so you could go into it. But if you didn't know that it was there, you couldn't get a listing of them. Or you can even lock it down more. What we did was, I think the group that was set up was the web server. So that instead of you owning the group instead of your personal group owning your home directory, it was the web server's group. And then everybody else had no access. So no one, even if they knew the name of your home directory, could get into it. The web server couldn't get a list of the files in your home directory, but could traverse into it, and then would have access to like your public HTML folder, but none of your other files.
Sure.
And, there's a lot of interesting things you can do with that, especially with ACLs where you can have more than one group having permission to a directory and so on.
So, of course, these techniques are mostly useful on a multi-user system, or in your case, like you said, a shell server where you're doing other shared hosting.
Or a web hosting server where there's a lot of separate users rather than just your own sites and so on. Yeah.
That's right. But one of the next, of course, answers to the whole privilege and containment is cheroots, which you guys, I'm sure a lot of you are familiar with cheroots, but they've been around since pretty much the late 70s. And of course, on all the BSDs and non-BSDs, they pretty much change what appears to be the root directory for a process.
Right. So, you can
of
basically take a program and say, the root of your file system is actually this subdirectory, so you cannot access anything out of it. And, that locks it down fairly well. There are some downsides to it. If you're actually giving someone a shell in a chroot, if you haven't copied, /bin/sh into that chroot, they don't have the ls command, and then you're basically having to install every tool that they might want in there, and can get kind of complicated. And some of the times I've looked at it, you end up doing static versions of the binaries, so that you don't also need all the libraries they might depend on, and it saves you a lot of help.
Yeah, makes it a little more difficult to manage.
Depending what you're having the user do, sometimes you don't really need that much. If you're just chrooting them for like FTP or SFTP or something, if either the FTP daemon has built-in like ls and so on, like SFTP does, or you only commands they need are like ls and chmod, and you can build static versions of a couple of those and give them that.
Okay. Well, of course, there's some downsides to chroot as well. It's not a be-all, end-all. Of course, users could run, if they have the top command, for example, they could see what's happening on the host system, and that may or may not be good.
And the biggest one is if you're root in a CH root, you can still do anything that root can do except for get out of the CH root. So you can kill other people's processes. You can, run ifconfig if it's in the CH root. You do all kinds of things, including mount file system. So you could probably do nullfs to mount the root file system inside the CH root somewhere so that you could then access the files outside of it and so on. So yeah, CH roots are really more of a convenience thing, right? They're originally written for the build process for doing releases. It's like, all right, let's CH root into this directory and run all of our install commands so we can use absolute paths and so on.
It's also a good convenience utility. So I use chroot still a lot when I have to repair a system. For example, I boot up a boot CD or whatever, and then I can mount and chroot into
and again, it's simulating
the
being
disk.
in that absolute system while still having the tools from outside and so on. Yeah.
Correct. Yeah, not caring about the security so much, but more of I just need to act like I'm on this system so I can run commands and stuff, and definitely is useful for that.
Yes. I say.
So of course, go ahead. Al.
I was going to say, most, if not all, daemons in OpenBSD are already running in separate CH roots by default, and that they have even a modified version of TCV dump that can run in CH root as an unprivileged user. I'm not quite sure how that one works.
Nice. So, of course, the logical evolution of chroot would be jails. So you've probably heard us talk about jails a lot if you've listened to the show for any amount of time now. But those are a feature exclusive to FreeBSD. And think of it as, chroot++ or an improved chroot.
Kind of.
And that's probably
it's
what we talk about the most
basically
here.
In a jail, you have what's called basically a namespace. You have a separate version of everything. So you have a separate list of processes that are running. You have your own init that runs in the jail. You have your own separate user space. So you can, if the first user on your system usually has the UID 1001. Well, in the jail, user ID 1001 can be something completely different. And if you're inside a jail, you can only see when you run top, you only see the processes that are inside that jail. So basically, you just have a separate version of every kernel memory structure, basically. All the stuff you would want to do, except for they're all completely isolated. So jails can't interfere with each other or the host system.
Yep.
One of the other interesting things about jails is basically because you have a version of everything, it's like virtualization, except if you're on the host, when you run top, you see all of the processes. And you can turn on an extra column to see which jail each process is in and so on. And there's a port that provides a bunch of interesting tools to make it easier to manage many jails on. But you have that ability to look inside
within the jail too, because I can log into the jail and run PS and see just the processes running in that jail and not get mixed up with all the host processes or other jail processes.
And if you have vimage, you get everything, including your own networking stack, so you can have a completely separate network configuration in the jail.
Yeah, that's definitely
they're a little bit heavier weight than a CH root because basically you're going to install the entire operating system in the jail because you need everything because you're completely isolated. But that's this space is cheap at this point.
I mean, especially if you're used to running VMs and needing huge disk images, this is still very minimal. So because you don't need the kernel, you're saving all those spaces as well. But of course, like you mentioned, host system can peek into the jail. Kind of think of it as a one-way mirror where they can't see out, but you can see in, which is very nice. And a user land compromise in the jail, so even root level should stay within the jail is kind of the idea, right? So even if they get root, they still can't go run mount nullfs or whatever and do trickery to try and break out into the main system.
Yep.
And of course, do we want to mention performance about that, Alan?
The biggest difference over VM is that you're not emulating the disk at all, and so you're using for example, if you're using ZFS, you're using ZFS directly on the host. There's no virtualization in the way, so you're getting the full speed. And ZFS is, as far as ZFS is concerned, everything happening in jail is just a file in a directory, and you get the full performance. And if you do a separate data set for each one, you get so on. And you're not wasting memory on multiple kernels and so on. But the disk performance, performance in general in a jail is going to be as good as it was on the host. There's basically no overhead at all. So it's better than virtualization. But the biggest...
Yeah, it's not uncommon to hear about guys running thousands of jails on a single system.
Jails, since I think FreeBSD 6 or 7, can be nested. So you can run a jail inside a jail. inside a jail. I don't think there's a limit to the recursion. You can just go. Or if there is a limit, it's like 256 or something. You can definitely do jailception. But
that's right.
Yeah,
that's right.
The jails give you, and there are a lot of tunables to laxen the restrictions on jails if you need to do certain things, and it can basically allow you to have your root level, your first level of jails be less restricted, and then inside of those create more restricted jails and so on. And you can do all kinds of interesting things. The other great thing about jails is they actually have integration with ZFS. So you can take a data set on ZFS and delegate it into a jail. So now root in the jail can run the ZFS command and create their own data sets and their own snapshots. And basically everything root can do on the host, but only on the data set you've given them access to. And all those data sets are basically respect the chroot. So the mount points are relative to the jail. And it has all the features you need to make sure that there's nothing the guy in the jail can do to take over the host system. And in newer versions of ZFS, you can also set limits. You can say, I've delegated this data set to this jail and let some user just run with it. I'm going to put a limit. They can't create more than 1,000 data sets so that they can't bog down the system, or they can't create more than 100 snapshots. Because at one point, I think someone on Solaris Zone just set up a for loop and just created data sets until it crashed the system. And somebody's like, yes, we should put a ZFS property in to stop them doing that.
That's right. Well, in addition to disk limits, you got also resource controls as well.
Yes, there's
so you
RCTL.
can say this much memory, CPU as well.
You can limit,
so definitely some neat
and
stuff.
with DummyNet, you can limit their network traffic, and you basically get all the advantages of a VM, but with none of the performance drawbacks.
With less of the overhead. Okay, well, one of the last things, of course, is something newer, but Capsicum/systrace. So, of course, Capsicum, we've talked a little bit about that in the past, usually on FreeBSD, but not necessarily exclusive anymore. And, of course, systrace, again, usually on OpenBSD, but not necessarily exclusive. They take a little bit different approach to containment, and instead they're trying to limit the abilities of a certain binary. So don't actually
but Capsicum is even finer grained than that. For example, TCP dump. It needs root privileges to open the interface and put it in promiscuous mode. Once it's done that, it doesn't need root privileges anymore. So Capsicum allows it to do the stuff it needs the privileges for and then give up its privileges in a way that it can never get them back. And so normally you can separate it enough where it would be able to do the two separate, where it needs to be able to be privileged, but not at the same time. And Capsicum allows you to basically draw that line in the sand and say, I needed it to do this, and now we don't. And for example, Capsicum, what you can do is you can open the files you're going to need, and then when you enter the sandbox, you have those file descriptors, but you have no access to any other files. So, with a chroot, if you chroot somebody into a chroot and they open a file, they can also open other files that happen to be in the chroot. With Capsicum, once you sandbox them, they can't open any new files at all. So, when this makes it into Chrome, if somebody does exploit it somehow and have access to it, they wouldn't be able to open any other files on your computer, even ones, even if Chrome is only running as your user, they still wouldn't have access to any of your files. They would only be allowed to access the files that are already open. Yeah.
Of course. So this is a little bit more of a policy-based system, but in addition, syscalls can be allowed. Allowed as well.
What systrace does as well. And that you can basically decide exactly what capabilities the program is going to keep and what it's going to lose, and control exactly what's going to happen. And the difference of these ones, I guess, with a jail or a chroot, when you can just run a program on modified. With Capsicum and systrace, you kind of have to implement it in the code of the program to make it do that. But the same kind of applies for privilege separation. Yeah.
Well, so out of all those, you guys would be curious to hear from you. Which ones do you like, or different use cases where you maybe implement, all these together or bits and pieces of them to do your own privilege separation? And if you have ideas on improvement or whatever, things you'd like to see them do in the future, we'd be curious to hear your thoughts. So, of course, the email for that is feedback@bsdnow.tv. So send that to us so we can take a look at that when we get back from BSD
it'll be
Camp.
interesting to see the presentation on Cherry BSD because it's basically taking the ideas of Capsicum but actually enforcing them in hardware instead of just software.
Yeah, I definitely see where they're what
And
progress
I guess
they're making.
the
with
advantage that it might be able to apply some styles of capsicum restrictions to an unmodified program by implementing them lower down.
Interesting. Yeah, I definitely have to go hear that. Okay, before we hit the feedback, of course, we want to mention TarSnap right now, where, come on, you should know by now, you need to be doing your backups offsite. This is not rocket science. This is kind of a solved problem, right? You need to do backups because you don't know what's going to happen to your local hardware or your systems, or when something's just going to randomly fail on you. And of course, if you're going to do those backups, you should probably do them in a way where you can trust that the remote end's not sitting there looking at all the data that you're storing on their system. So TarSnap makes that super simple with a really nice tar-like interface where you can just, if you know tar already, the command line is really simple to get started there. And of course, it's available on just about every platform under the sun, including they even have a Windows port for Cygwin, which how crazy is that? But hey, if you need to back up files on Windows, that's a perfectly legit way to do it. And of course, the source is all freely available, so don't take our word for it. Don't take Colin's word for it. Go actually look at the code yourself, audit it, make sure it's doing exactly what we're claiming it'll do.
And you
here.
can compile your version from that source so that you don't have to trust the binaries.
That's right. So definitely go get that set up now, guys. That's tarsnap.com/BSD Now, or you can go put a few bucks in there, which will last you a long time because it's really, really cheap to do your backups, and then get it rolling. There's no reason to delay any longer. Okay, so first up we have Brad, who writes in about a follow-up. He said, I finally got to watch BSD Now episode 90, and he heard Alan's request for the SmartD output. He said, I have 2 drives in this machine, the SpinPoint 1.5 terabyte that has PCBSD on it, and a 750 gigabyte Samsung that has Debian on it that I'm about ready to retire. And then he lists some of the output here from eMessage. He said, at Alan's urging, I ran SmartCTL-A on both drives. I looked at the current pending sector values. However, the one on ADA00, but the one on ADA1, the Debian drive, is at 57. However, the ADA0, the UDMA CRC error rate, is at 33. He said, note these are both the raw numbers rather than the threshold values. Does that make a difference? And then he posts all the output here.
Yeah, so the threshold value doesn't usually change. That's the one that when the rate goes above or below or violates that number is when the drive is considered unhealthy. So the CRC error rate usually isn't a big deal. I think it's just, the rate of errors when it's copying files off of it. So it's not a big deal. The pending sectors usually is the one you have to worry about. Looking at the first drive here, his temperatures look nice. He's got some end-to-end errors. I forget what that means, but that's usually a little strange. But in general, it looks pretty good. Looking at the power on hours, the drive's over 5 years old. That means it's getting pretty old. It is 1.5 terabyte, but 5 years of being powered on, you're definitely out of warranty period at that point. But yes, the Samsung is definitely having issues. The pending sectors mean that, it was tried to write to it and couldn't, or had to somehow rearrange and use some of its replacement sectors. As you can see, the relocated sector count is 20. So 20 of the sectors were bad and been relocated to a different place on the disk. And there are 57 that that's waiting to happen to and isn't happening for some reason. So yes, it definitely seems like that older 750 gig drive is dying on you. And looking at the power on hours,
put it out to pasture.
Looking at the power on hours, you're looking at 6.5 years already that you've put out of that drive. It's definitely time to retire it.
Yep. So when you're ready to retire it, usually a small object, roughly 9 millimeters in size, traveling at high velocity, really tends to put the final nail in the coffin for these dudes. So.
Or an actual nail in a hammer is fun.
That works too.
If you would like to see experts do it, you can check out the videos from MeetBSD, where we have a whole series of people trying their hand at destroying hard drives.
Yeah, file system developers in particular. Yep. I hate you. Just pounding those suckers to death. Yes. But yeah, it's going to be time to retire these dudes. Okay, so next up, Anonymous writes in with a ZFS backup follow-up. and I don't remember what the original one was, but he says, bummer, initial tests seem to show that when a drive is pulled or fails, the controller takes that channel offline until you go into the firmware interface, reboot, and then settle it at that level. So putting a new drive in live does not result in a new dev appearing, which can then be added to
So
the
this
pool.
is a follow-up
that
from
is a
an
bummer.
existing. So some controllers have a command line utility in BSD where you could maybe do the part you have to do in the BIOS, but some of them don't, yeah. And this is basically the reason why we recommend you don't use hardware RAID, but instead just a cheaper, plain old HBA, because it doesn't have that problem.
Yeah, that's right. He says, we still want to use BAdmin, which is boot environments, and snapshots, though. So we plan to do a single volume pool that is really hardware RAID 5E underneath. Weird, I know, but it's this or straight UFS.
This is the thing we warn people not to do, mainly because ZFS will detect silent corruption or something and not be able to fix it. Or if anything goes wrong, there's nothing ZFS can do because all it has is the one copy of everything. If you can, you might consider trying to break it up into 2 devices. I think in your setup you have 6 disks, so then you're looking at 3 mirrors instead, or something like that. Although you're not quite getting the same space efficiency, you would get 3 drives instead of 4. But then you would have ZFS with spreading the data out better, and you stand a better chance that way. But what you're going to do will work. It's just you lose some of the advantages. If you have some really important files, you might try copies equals 2, but
yeah. But still, I don't know, just running it on top of hardware RAID.
Yeah.
That's just all the icky factor for me goes way through
yeah,
the roof.
we explain all the way, well, not all, a small smattering of the ways it can go wrong when you use hardware RAID in the FreeBSD Mastery ZFS book that you can buy at zfsbook.com. The print edition is out now, by the way.
Nice. Okay. Let's see. So I guess that pretty much answers those questions there.
So next up, Benjamin writes in about PF redirects. He said he read a tutorial about OpenBSD PF and tried the rule using our tutorial, passing quick on the internal interface proto-TCP from NA to ubuntu.com redirect to bsdnow.tv port 80. And he has a question about it. When I put YouTube instead of Ubuntu, I get an SSL error. When I put Facebook, it just opens Facebook. This is redirect from Ubuntu does work. Why is it not working with Facebook? The main problem is when you put just a domain name like that in a firewall rule, it does a DNS lookup and gets one IP address. Well, Facebook.com has more than one IP address. So you're only blocking one particular node of Facebook, and that's why it's not going to work. Yeah, that rule is mostly just a joke. It wasn't actually meant to do anything like that. And getting an SSL error when you try to go to YouTube, that's what's supposed to happen because BSDNow.tv is not YouTube and doesn't have YouTube's SSL certificate. And the name YouTube.com doesn't match the name on our SSL certificate.
Okay. Next up, we have Jaron writes in about file systems. He says, hey guys, really like listening to your show. I've been running Linux on the desktop for quite some years now. First SUSE, then Debian, and now Ubuntu. And the last years he's been using Gentoo Linux. He said, now after some bad experiences running recent stable Linux kernels, I decided to try and make the switch to FreeBSD and start using a ZFS mirror on 2 3-terabyte hard disks for backup and storage. All went well installing FreeBSD, setting up disks, file system, etc. He said, however, I've only had some partial success migrating to FreeBSD, though. I'm stuck with 2 older 750 gigabyte NTFS disks, which came originally from an older Windows box, which have never operated in RAID mode before. After connecting these devices, they do not show up in FreeBSD using gpart show. However, getting some hints from dmessage, the graid status command shows a degraded RAID device containing 2 physical devices, ADA2, ADA4. One device shows as active, the other shows active rebuild 7%, and then this percentage increases slowly. Having no experience with software RAID and a bit scared that this happened so suddenly, should I let it rebuild, and is it possible to mount the NTFS afterwards? Or is there a way to remove this particular configuration while preserving the data on at least one of the disks? My intention was just to mount the ZFS file system to copy the contents to the ZFS mirror. Hope some of this data is recoverable. Curious to hear your take on this.
If the 2 drives are completely unrelated, then if it finishes that rebuild, then the second drive is completely a copy of the first drive.
Yeah.
It's weird that if they were never in RAID that it would do that. I've seen it do that, but every time I've ever seen it do that, the person eventually admits that, oh, yes, it turns out this was in RAID in another machine, maybe configured by someone else, not me originally, but it did have some RAID metadata written on the drive somewhere, and the FreeBSD driver picked that up. Although it auto resyncing is a little strange if they weren't.
It is a little odd.
But I guess if they're two identical drives and they were in a mirror at one point, then it makes sense that it would do it, I suppose. Because the second drive would have had to have the metadata as well in order for it to do that. So it looks like they were in a mirror at one point and then were split up. Once, whether it rebuilds or not, you should be able to read the data off the one that was the master.
Yeah, the first one.
So you can do the graid forget, I think it is. Double checking here. Graid stop, and then R0 or whatever the device name it came up with was. And that might help, but yeah, you'd if you do graid remove R0 and then ADA2 or whatever, that will remove that device from the RAID thing, and then you should be able to see it as a regular, ADA2 or whatever.
Then just run your mount NTFS.
graid delete -F, and then R0, and it will delete the RAID metadata and stop doing what it was doing. But I'm pretty sure the data on the second drive has been clobbered by now, sadly.
Yeah.
It's a little strange. I guess, when they have the metadata, it thought it was doing the right thing.
Okay. Well,
I've only seen that causing problem when someone was trying to reuse one of those drives, and it just wasn't showing up. And but even like graid show or something wasn't showing up. We ended up having to, when somebody took the conf dot, the XML data that Geom puts in sysctl and actually graphed it, that's when we saw this extra Intel RAID device showing up. And we're like, what was that? And eventually figured out that the problem was actually that the user had it configured in a BIOS RAID at one point, and FreeBSD's graid driver understands the metadata for most of the popular BIOS RAIDs, so that if you have them configured to mirror there, FreeBSD can do it in its mirror, and then you have your files not getting munged up.
Okay. Well, since he sent this in yesterday, I assume the rebuild either finished or that's all done. Yeah. So the second drive, like you said, it's toast. But,
well, it probably contains a perfectly pristine copy of the files off the first drive.
That's true. But hopefully, you've had a chance to mess around with this. Be curious to hear a follow-up. If you were able to mount the data or mount the file system and read back your NTFS data.
Either mounting it as the R0 device once it's ready. Well, even in the graded state, it should have showed up in gpart show.
Yeah, still one copy.
Then you'll just need the NTFS 4G thing from ports, and you should be able to mount it and copy your files off.
Okay. Cool. Well, thank you for writing in. We appreciate that. So, of course, as we close out the show here, folks, we'll be back from BSDCan next week with a ton to tell you about, I'm sure. So you'll have to stay tuned for that. But, of course, in the meantime, if you have questions or comments or any other topics or ideas, stuff you want us to talk about on a future episode, get that sent in now so we can get that all queued up while we're gone and be ready for us when we get back. And, of course, hopefully we'll have a list and kind of tease you with some of the interesting interviews we got from BSDCan. So, we're going to be having a lot of fun. So I'm sure we'll be tired when we get back, but excited to talk to you about everything that happened out there.